What is up, math superstars? In this edition of Mr. Peterson Presents, I'm bringing to you lesson 1.1 on ratios. So at the end of this lesson, you will be able to describe and compare data using ratios, and you'll be able to use the appropriate notations. So the question is, what is a ratio? For your notes, a ratio is a comparison of two quantities by division. So here we're given our first example. We're going to write the ratio that compares the number of footballs to the number of tennis balls. So our very first step is we're going to underline some key information that's going to help us answer this example here. And so we're going to underline, so we're looking for the number of footballs. The word two tells us that we have a ratio problem. And we're going to go ahead and underline the number of tennis balls. And so before we even write the ratio three ways, what we're going to do is we're going to count the number of footballs first. So we're going to write footballs. And we're going to go ahead and count them. So we have 1, 2, 3, we have 4 footballs. And let's go ahead and count the number of tennis balls now. We have 1, 2, 3, 4, 5, 6 tennis balls. And our directions are, when we write ratios, we can write them three different ways. We can write them, first thing is fraction in simplest form. And so let's go ahead and write the fraction. And so we're going to use the order that this example is in. So we have the number of footballs as our numerator. So we write that as 4. Our fraction bar is the 2. And the number of tennis balls, which is 6. And so this is not in simplest form. We know that we can divide the top and the bottom by 2 to simplify. And so we know 4 divided by 2 is 2, and 6 divided by 2 is 3. And so we have our ratio 2/3 is our fraction in simplest form. Another way we can write ratios is using the word colon, or using the colon, and it looks like this. So what we do is we take our fraction in simplest form here, and we can write that as 2:3. And then we can use the word 2 to write out our ratio. So we're going to take our fraction in simplest form again, 2/3, and we're going to write that as 2, the word 2, 3. So here's our second example. So go ahead, let's pause our video, give this a try, and the video will start, and it's asking you this question. Write the ratio that compares the girls to the total number of students, and we're going to write the ratio three ways. So first of all, we need to figure out some useful information here. So it says write the ratio that compares the girls. We're going to circle the word 2, because that's going to tell us the colon, the fraction bar, the word 2. And then we're looking for the total number of students. So first step is we're going to count the number of girls here. So write down girls, and we need to come up with a total. So the number of girls here, so we have 1, 2, we have 3 girls. And let's figure out how many total students we have here. So we have 1, 2, 3, 4, 5, 6, 7, 8. We have 9 total students. So the first step is we're going to write the fraction in simplest form here. So for number 1, our fraction, so we have girls is the numerator, the total number of students is the denominator, 9. But we know this is not in simplest form. We know that we can divide the top and the bottom by 3, our greatest common factor. When we do that, it simplifies to 1/3. So we can say for every 1 girl, there are 3 students. So our next step here is we're going to use the colon here. And so we're going to use the fraction in simplest form for the colon. So for number 2, we can write this as 1:3. And then we're going to use the word 2. So we can write this as 1, 2, 3. So another thing with ratios, we can talk about equivalent ratios. So these are two ratios that have the same value. And so we're given a couple examples here. So we have 3/4, or 3/4, and we have the ratio 12/16. So the way this works is we're going to simplify both fractions. And so 3/4 is already simplified. 12/16, our greatest common factor here is 4. So when we divide 12 divided by 4, that equals 3. 16 divided by 4 is 4. So we know that, yes, these are equivalent ratios because 3/4 is equal to 3/4. So the key for equivalence is simplify. But in our second example here, we have 12/17 and 10/15. And so key here, let's try to simplify. So 12/17 is already simplified. Let's go ahead and simplify 10/15. So we're going to divide the top and the bottom by 5. So when we do that, it simplifies to 2/3. And so right now, we're kind of stuck because we say, okay, how big is 12/17? Well, the way we can do this is we're going to rewrite this in 2/3. We could cross multiply to figure out if these are equal. So what we do is we take 17 times 2 equals 34, and 3 times 12 equals 36. And so when we cross multiply here, if these two numbers are the same, 36 and 34, they would be equivalent. But since they're not, we can say that these are not equivalent or equal. We'll do a little sad face.